I think we can get started. I'll wait a few seconds till everybody's seated. But I'd like to thank you all for coming. It's late in the day, and it's very brave of you all to come listen to me rant about passwords for an hour. So thank you very much. If you like passwords, this might not be the talk for you, because I understand if you want to leave the room right now. If you're really passionate about passwords, this might not be the talk for you, because we'll go through some ways and some things I don't like about passwords, and we'll go to a future where maybe we don't need passwords at all, hopefully. But let me quickly introduce myself. My name is Bellen. I'm a senior developer advocate engineer. That's a whole mouthful at Auth0. And at Auth0, we're an identity as a service provider, which basically means that we try to make it as easy as possible for anybody to implement a secure authentication flow, so you can focus on building your actual products, your applications that you want to build, not that stupid login window and those registering users. I'm also a Google Developer Expert, and you can find me on the internet as @Sambego. And I have a confession to make. At the beginning of this pandemic, I started to learn Norwegian, and I've been learning Norwegian for 592 days, and I don't understand a word. There's a very big difference between Duolingo Norwegian and real Norwegian, but I keep on trying, and maybe one day I will understand everything you all say. But so far, this experience has been amazing here in Oslo, so thank you for that. So, what I'm going to be talking about today, we're going to start with a little bit of history on passwords, going way back in time and see where passwords might have originated, maybe before that, but we'll see. We're going to see a bit of different types of passwords. We'll transition into passwordless authentication, and lastly, but most importantly, the point of this talk, the Web Authentication API, which might lead us to a future without passwords on the web, hopefully. Cool. If there's any questions, feel free to type them in the app. I forgot the name, but just type them where you need to type, or just ask them at the end of my talk. But let's get started with a bit of history on passwords. I will start somewhere before Christ, a long, long, long time ago, thousands of years ago. Passwords have been proven by archaeologists or whoever studies Romans and old things that the Romans used passwords to determine friend from enemy. So if two galleons of Romans would encounter each other and they didn't know each other because the Roman Empire was huge and not everybody knew each other personally, they would often use a password to determine if they were supposed to be enemies or friends. So they would ask the password, the other group would say the password, and whether that password was correct or not would determine if they would have to fight for their lives or just grab some beer and have some party together. So the Romans used passwords to determine if they would live or not. We skip forward a little bit to the 10th century. There's the story of Arabian Nights or 1001 Nights with the famous cave where Ali Baba stored all of the gold and jewels that he found all over the countries. And that cave had a password to open it. It's Open Sesame. So whenever anybody said Open Sesame, the cave would open and everybody would get access to gold, jewels, all the riches of the world back then. But let's skip forward to a more modern era. 1961, and Fernando Corbato is considered one of. There are multiple people who have been working on time-sharing systems, but has been credited as one of the people that founded a complete time-sharing system. And a time-sharing system, back then in the day, not everybody had a computer in their pocket, like a phone or a computer on their desk. Usually, a university had one big mainframe, and that was it. There was one big computer because they were huge, they were expensive, but they wanted to have as many people use that computer at the same time. So they figured out a time-sharing system where you had this big computer and multiple terminals so people could use the computer at the same time. Whenever somebody else wasn't using that computer, somebody else could. And they used a password to determine which files they could access on that time-sharing system. Because it's one computer, you only want to access your own files. So that's one of the first instances of a password used with a computer. If we skip forward to the 1970s, Robert Morris Sr. invented hashing, which basically means that for the first 10-ish years or so, passwords were stored as plain text. And hopefully by now we all know we don't store passwords as plain text in our databases. And then from the 90s, hacking became more of an issue just because the web exploded. Everybody wanted to be on the web. You hear these .com bubble stories. Every company wanted to be on the web, including criminals or people with bad intentions. They also wanted to be on the web, so hacking became more of an issue. They tried to figure out clever and ingenious ways to get to the data they were not supposed to. So hacking became more an issue, and we had to look more on how to secure our data and how to store passwords and other things securely in databases. Cool. That was a short history of passwords, going back to the Romans, all the way to right now, where we are using passwords on a daily basis multiple times. So let's look at some different types of passwords. But first, what is a password? To me, a password is anything that is a shared secret. It can be a string, can be something else. As long as it's a secret that is shared between me and a third party, I consider that a password. The first one is the most used one. It's a string. It's what you use on the internet all the time. A username and password combination. It's a bunch of letters and numbers stringed together. And my first password when I created my Hotmail account back in the day, because MSN was a big thing back then, was CallDog. Don't know why I chose that name. It's not my password anymore. Don't try it. You will not be able to use it as my password. But usually it's a more randomish looking string. Or hopefully it's long enough. But it's a bunch of characters put together. And the downside of this is they can be hard to remember if they are complex, and hopefully they are reasonably complex and reasonably long. But a password manager can help us remember those passwords. But they can also be hard to guess by others, people with bad intentions, which means that they are somewhat secure if they are kept securely. And another form of a password is a PIN code. We all use this on our phones, on our banking cards. Maybe if you want to enter a building and you need to type in a code to open the door. This usually is 1, 2, 3, 4, 5, 6, a bunch of numbers together. But usually it's quite short, 4, 5, 6 numbers only. Which means that they're not that hard to guess, because if you only have 4 numbers, there's only so many combinations that you can make with those 4 numbers. So if you give enough time to anybody who wants to, they will be able to guess the PIN code. But the upside is that they're often combined with something physical, your ATM card, your cell phone, that padlock on the door. So even if somebody knows that PIN code, it's usually not enough. They will have to get access to that physical thing, that keypad, that card, that phone, to actually use that PIN code. And because they're so short, they're fairly easy to remember, which makes them quite easy to use. And like I said, they're usually you can only access them with a physical thing. Next up, it's a pattern, and everybody who has an Android phone has the opportunity to use this to unlock their phone. Are there people in the room who use this to unlock their phone? I see some hands. Okay, there's a lot of security-focused people in here, because there are some issues with this, but it's very convenient. And why people use this all the time is because after you use that pattern a long time, it will get into your muscle memory, and you can basically unlock your phone without even thinking about unlocking your phone. But behind the scenes, this pattern will just boil down to a password as well. And one of the downsides is a touchscreen can often reveal the pattern as a dirty spot. I don't think any of us clean our screen every time we enter a PIN code or a pattern. So if you are aware of that, your touchscreen can reveal the pattern. And people often use a pattern that is related to themselves. Maybe it's the first name of their first name or last name, or it's a number from their date of birth. So if you do some social engineering, you can often find out this pattern, because we tend to use something that is relatable to ourselves. But like I said, muscle memory, it's just a simple pattern. They're easy to remember. So what's the problem with passwords? This is a common thing we see on the internet, username and password, and we try to log in. So if we click on the button, first try, you never type your password correct from the first try, so you try again, and you click it. Second time, still something wrong, so third time's a charm. Nope. What you do, you say, okay, I forgot my password, I'm going to reset it. So when you try to reset your password and click on it, turns out you knew your password all along. But you just are not able to type because people are watching you while you stand on screen. I don't know. So oftentimes we do remember our passwords, but we just don't type and write because it's something that's a nuisance to do. It's something that's not nice to do. It's something we have to do, but only because we have to. So passwords can be very, very annoying, at least to me. So if you use a password manager, and I can recommend everybody to use a password manager, they can help you remember those passwords, they can help you input those passwords, but it's another extra step on top of using those passwords. So the user experience is not the nicest, because you have this extra step on top. It's another software that you maybe have to pay for, even though it's worth the money. It's always something extra. And with passwords, user data can get stolen, and we all know that user data does get stolen. I have a few examples from 2019, but if you get closer to today, the numbers in these examples will just keep on increasing because people keep on stealing user data. So in 2019, Marriott Hotels, 283 million, Facebook, 550 million user data, MoviePass 160, Words with Friends 218, people data lab 1.2 billion user records. Now, I'm not saying that they contain plain text passwords or passwords at all. I'm just illustrating that people try to steal that data all the time. And if they can get a hold of the password stored in your databases, they will definitely try to do that. And if you use Auth0, we have a breach password detection feature which lets users and admins know that somebody is trying to use a username and password combination that has been known to be reached. And if you use a Chromium browser, the Chromium browser will also be able to tell you, hey, you're trying to log in with a username and password combination that has been known to be breached, that has been known to be found on certain databases with breached passwords. So I recommend you to look at these messages if you see them and take action, change your password if you can. Okay, lastly, some tips for a good password. Use a reasonably long password. Length is more important than complexity. Both are a good combination, but length is more important than complexity. Don't use personal data just because people might be able to guess it. Don't use the name of your cat or your dog. Use something randomly if you're able to. And don't reuse passwords. Create a new password for each service and each website, each mobile app that you use. Because once a password gets leaked, people will try to reuse that password with any service they can think of. It's called credential stuffing. Credential stuffing attacks. So try to use a new password for each service so this doesn't work for you. Cool. Let's get forward a bit. Passwordless. One-time passwords, I think we all use them. At least a lot of people use them these days, mostly as second-factor authentication, so a second factor on top of passwords. But they're valid for one-time use. They often expire after a certain time, and they're sent directly to the user. So that's something that you don't have to remember. It's sent to you in the moment that you need to use the one-time password. So this can be sent as an SMS. And iOS and Android will let you just fill the one-time password with the press of a button if the website is configured correctly, which is quite convenient. You don't even have to type the numbers. You just press the one button from Messages on top of your keyboard, and the one-time password is filled in. But unfortunately, not telecom operators take security serious, and SMS messages can be intercepted. Doesn't happen a lot, but it's always a possibility, so that's a downside to this. And you need your cell phone at hand. If you're working on your computer and your cell phone is upstairs, you need to run upstairs to get your cell phone to see that message, which might be annoying as well. And instead of being sent in an SMS, you can also send them an email. Slack, for example, has this email mail link where you have a magic link with a one-time password attached to that link. A lot of services do this as well. And the good thing is you don't need a second device because usually you have your mail set up on the device that you're using right now. But also, emails can be intercepted. They're not 100% secure, so people might get to your password before you do. Just be aware of that. An authenticator app is an application that will generate one-time passwords based on a shared secret between you, your service, the service, and the authenticator app. And these one-time passwords will usually expire after a certain amount of time. With the Google Authenticator app, that's about 30-ish seconds. Auth0 has their own, it's called Guardian, but there's many authenticator apps out there that either generate a one-time password or lets you log in with a push message, and then there's some of the magic behind the scenes. And the good thing is they're time-based. They expire after 30 seconds, 1 minute, depends on which app you use and how you configure them. They can be push-based, which means you don't even have to enter the numbers. You just press on a push message on your phone, and it does all of the things for you. But they rely on a shared secret between the application and the authentication service, which means if that secret gets leaked, anybody can create fake one-time passwords if they wanted to. So that secret is called a secret for a reason, needs to remain secret. Lastly, social login. It's not really a one-time, or it's not really a passwordless solution, but it's definitely a popular solution. Who uses this once in a while? I use it all the time, to be honest, because it's convenient. I know that I choose Google, and I know that if I have an account, my Google will probably be linked to it. And the good thing is, it's one less password to remember, because you just have to remember your password to Google, and hopefully that's a secure password. And you only give that password to a service you trust. You use Google in this instance to log you in. You don't use an external service, which is also something that I hope if you choose login with Google, you trust Google at least to a certain degree. But you rely on another service for authentication, which means if the Google Authentication authorization server goes down, you cannot log into many other applications, so you're reliant on a third party, which might be annoying as well. There are a lot of other authenticator apps as well. It's Meet Something Belgium. Yodi tries to do facial recognition and log you in with your face. VoiceIt does the same, but it tries to analyze your voice and log you in with your voice. And there's many, many other examples out there. And I think as we go forward, there will be many other examples for me to mention as well. And like I said, these one-time passwords are often used as a second factor. Doesn't necessarily have to be, but most of the time there is an extra step on top of using a password. But it doesn't have to be. And now we're getting to the real part of this presentation, the Web Authentication API. Who's heard of the Web Authentication API before? It's also abbreviated as WebAuthn. Cool, I see some hands, but I also see a lot of hands which have stayed down, which means that I can hopefully learn you one or two things. So like I mentioned, the Web Authentication API, or WebAuthn for short, because we're all developers, we're all lazy, is an API that has been standardized by the W3C organization. It's a browser API, which means it's implemented by browser vendors, Chrome, Firefox, Safari. And it allows us to do key-based authentication on the web, which means we use a private key and a public key to do the authentication instead of a password. So, key-based authentication, check. It also uses hardware authenticators. So instead of using an authenticator app, it mostly uses hardware authenticators, which are designed and built for doing one thing only, authenticating people. Or basically just creating a key pair, a private key and a public key pair. And there's a bunch of them out there. If you use one of these, you might have a YubiKey or you might have a Google Titan key. There's some open source alternatives out there as well. You have fancy stuff for the screen, which is Trezor, which is actually a Bitcoin wallet, but it can also be a hardware authenticator. And these days, there's many, many other versions of these keys as well. And they often look like a USB key, but they are not a USB key. You cannot store pictures of a cat on them. They do one thing only, authenticate, create a key pair for you to use in your authentication. And they can work over USB, they can work over Bluetooth Low Energy, they can work over NFC, they can connect your devices in multiple ways, because maybe you're using your phone and you don't have a USB-A connection to your phone, so you might want to use Bluetooth or NFC instead. So they work across devices with multiple transport mechanisms. So, who has one of these? Cool, I see a few hands. Very nice. If I would have brought mine, I would have shown you a demo using one of these keys, but I forgot mine in my hotel room, so we'll just continue with the talk and we'll see some other demos after this. But if I would have had my YubiKey or my Titan key, I would have attached it to my laptop, I would have clicked logged in, and it would have asked me, can you please touch your YubiKey so I know that you're present behind your laptop, and it would have created a key pair on that YubiKey and use a private key to sign a challenge, and then use that challenge to authenticate. But we'll not do this. But the good thing is that most modern devices have a built-in authenticator device themselves. So if you have a modern phone, if you have a modern laptop, there's probably a little chip inside of that laptop, inside of that device, that does the exact same thing. It creates key pairs and keeps them secure for use in authentication purposes. So if you have the same demo that I just skipped right now, instead of using an external YubiKey, I'm going to use the internal one of my MacBook. My MacBook Pro has a Touch ID, so it will ask me to unlock that chip, to unlock that thingy with my fingerprint. And basically what we're doing is logging in with Touch ID on the web. So if I click this, my MacBook is asking me, can you please touch your Touch ID? I do that. And we see login successful, and then we see some other data, which I will explain in a second. But what we just did was we asked our browser, can you please generate a public and private key pair, sign a challenge with that private key, and can you please let me know if that has been succeeded? And in order to generate those key pairs, my MacBook, which has Touch ID, will use Touch ID to verify that I am present behind my laptop, and I say who I am. If you don't have Touch ID or Face ID, this will usually just ask for a password. So, very cool. In essence, we can log in on the web with Touch ID, Face ID, not with passwords. So, how does this work? The first thing we need to do whenever we want to register a new device or a new user is create new credentials. It's the same thing if you use passwords. You generate a new username and password for any user you need. So what you're going to do is create new credentials, create a new key pair, a new private key and public key, private key and public key, and then register them in your backend services. So what we're going to do is the user tells us, I want to be called some, and it's going to send this to us, to the browser, to our backend. Our backend is going to generate a challenge, and a challenge is basically an array buffer with some random data. We do this on the backend rather than on the front end because we want to have a cryptographically secure random algorithm. So we do this on the backend, and we send that challenge back to the browser, which will then relay that challenge to our YubiKey if we have one attached, if we're using the internal one to our MacBook chip. But it will send that array buffer to that authenticator device, which will ask for a user interaction. And the Web Authentication API specifies that there always should be a user interaction, which means if you leave your YubiKey attached to your computer and somebody executes a malicious script, it will not be able to log you in without you touching that YubiKey or touching that Touch ID. So once you have a user interaction, once that's done, it will create the private key and the public key pair, and it will send back the signed challenge, which is signed using the private key, the public key, which is something that's public that you can share with everybody, and the ID of the private key. The private key itself stays on that authenticator device, but it will tell you the public key and the private key pair, and you can store those in your database, so you can use them anytime you want to log in a user. So once the user has registered and we've created this private and public key pair, we can authenticate the user. So what we do is, again, the user tells us, I'm Sam, and we look in our database, do we have a user named Sam? We do. So here's a challenge again. It's an array buffer with some random data, and we're going to tell the authenticator device, can you please use the private key with this ID to sign the challenge, because we have the public key belonging to that private key in our database, and we can verify the signature, the signed challenge later on, if you use the right private key. So we send this to the authenticator device. The user has some user interaction, touch the thingy, signs the challenge, and once we've done that, the signed challenge is forwarded back again to your backend, together with your public key if you want to, but you should probably have saved that in your database anyway. And you can use that public key then to verify the challenge, the signed challenge, to make sure that it's Sam who says who he is, that it's me who's trying to log in using nothing but the Web Authentication API. So to recap, you request a challenge, a random array buffer, you sign that challenge using a private key, and you send back the signed challenge together with the public key and the private key ID, so you can store them in your database. This is all public data. This is nothing sensitive. A signed challenge is just a challenge that has been signed by a private key. A public key is a public key, and an ID of a private key is just an identifier. The key itself stays secure on your authenticator device. And you save them together with the username, so that you know that next time the user wants to log in, you know which public key to request, which private key to request, and which public key to use to verify the challenge, the signed challenge. And when you want to authenticate, again, you request a challenge, request a private ID, the private key ID for the user, send that to the authenticator device, sign that challenge using the correct private key, and then send back the signed challenge so you can verify it on your backend with the public key you already have in your database. So let's look at some code. The first thing you want to do if you use this, it's a relatively new API. With relatively new, I mean it's about 2 years old, but on the web, things go either super fast or super slow. Adoption of WebAuthn is not super fast, so it must be super slow. So what you're going to do is check for support in WebAuthn. And that's a very, very long method name, but basically it tells you, yes, this browser supports WebAuthn, the Web Authentication API, or not. And if it does so, you can continue with your implementation. And the Web Authentication API are basically two methods that are being exposed in your browser. The first one to create those credentials, to create that key pair, and the second one to use those credentials to sign a challenge. So the first one is navigator.credentials.create. I know it's JavaScript and there's a lot of .NET developers in the room, but bear with me, it's just a little bit of JavaScript. And this credentials.create method that accepts a bit of configuration in the form of this public key object. And the first thing you want to pass along is the challenge, the random array buffer. So you put that in there, together with some information about the relaying party, the authorization server. In this case, it's my website, but this is the name of your website, the service that you're trying to authenticate with at this moment. And some information about the user. This can be a user ID and the name and display name. The one thing that you have to remember here is that the ID cannot be user identifiable. The name and display name obviously are user identifiable, but the user ID should not be able to be user identifiable. You can tell the authorization device, please use this algorithm because I know how to deal with it on the back end. And this algorithm -7 is just an algorithm that has been listed in the IANA registry, and it boils down to -7 boils down to the ES256 algorithm. So by supplying a list of algorithms, you can tell the public key, hey, if you know how the authorization device, hey, if you know how to use this algorithm, please use this algorithm, and it will take a priority from top to bottom. Lastly, you can also configure how much time the user has to perform all of the actions: touch the Touch ID, enter the password if you don't have Touch ID, use a Face ID, and this is in milliseconds. And you can exclude some credentials if you want to. And you can also configure which kind of authenticator devices you would like to use, and you can be quite fine-grained with this. You can either choose platform, which are built-in ones, or cross-platform, which are the YubiKeys and the Titan keys out there, or you can just leave it as default, and you can just use them both. You can set that user verification has to be preferred. Touch ID verifies the user based on a fingerprint. A YubiKey, which you just have to touch but doesn't read your fingerprint, it just verifies that somebody's there, but doesn't verify that I am there. That's just that somebody's touching it. And lastly, require resident key is something we'll see a bit in the future. And lastly, you can set attestation to direct, and this basically means how to send back attestation data, direct or indirect, and it will be anonymized or not. Cool, so once you've created the credentials, you can use those credentials with the navigator.credentials.get. Again, some config. The challenge, we've seen this before. This is the random array buffer. You can pass along a list of allowed credentials, and this is where you're going to plug in the raw ID, the ID of your private key that you stored in your backend. So you're going to say, hey, please use this private key with this ID for starting the challenge, and then you can choose if it should be transported to USB, NFC, Bluetooth Low Energy, all of them. And lastly, again, user verification preferred. But basically, because you here say which private key the authenticator device needs to use, the authenticator device will look at this, check if there's an ID, if there's a private key with the ID that's specified in this array, and use that one also in order that you specify them. So that's what you do in the front end. Just two browser APIs. What do you do on the back end? Well, when you create a new credential, in the end, you'll get back an object that looks like this. It contains a raw ID, which is an array buffer. It's an ID of the private key, and the ID is just basically for encoded the same ID. The type, a public key, and a response, which contains client data JSON and attestation an attestation object. And the client data JSON is just some plain JSON, which tells us we use the WebAuthn.create method. The challenge that we signed, the original challenge, is this one. This is the origin, and we're not expecting something cross-origin. The attestation object is a bit more complex. It's also not just in plain JSON. It's a CBOR object, which you have to decode first. But it will tell you things like the public key information, which you'll see in the credential public key object. It will tell you some flags, as did the user actually verify himself, or did it just touch? And it will also give you some more information about the attestation statement, which basically tells us which device created the public key pair. So we validate the returned authenticator data. It's the first thing you need to do. Is there an ID in it? Do you have an ID for a private key that you can use later on? You validate the returned client data. Is the challenge the one that I originally sent to it? And is the origin the one that I expect it to be? You validate the returned attestation data. Is the attestation data correct? Is it the device that I expect it to be? And you save the credential ID and public key data in your database. So next time, when you want to verify an existing credential, when the user wants to log in, you get back a different object, which has the signature, which you can then verify using the public key that you stored previously, together with the user handle, which is basically the user ID that you passed along in the first step as well. Some client data JSON, WebAuthn.get, the challenge, the original challenge, the origin, and cross-origin, like we saw in the previous example. And lastly, some more information about the authenticator. But basically what's important here is that you get a signature that you can verify using the public key that you stored when you created the credentials in the first place. So what you need to do here is a bit less involved. It's just you validate that the user, the challenge, and the origin are the ones that you expect it to be. And you validate the return signature based on the public key data that you have stored in your database linked to that user. And it's important to know that you can store multiple credentials for a user, because if I have my laptop here and my phone here, they will have two different credentials, and I will be able to use both of them if I store both of them linked to my user in my database. So, lastly, before I show you some demos, resident credentials. What resident credentials are is basically, instead of saving the username in the database, you can also store some user identifiable information together with your public and private key pair on your authorization device, authentication device, which means that you just need to plug it in or touch your Touch ID or whatever you have in your device, and it will give you a list of profiles that are available, and you can just log in with the click of a button. And you do that by setting require resident keys to true in the configuration object that you can pass along to the navigator.credentials.create object. Okay, so what I have here on screen is WebAuthn.me, which is a website that I created for my company, for Auth0, and it basically has a tutorial on the front page which lets you see the back and forth between the authenticator device, the browser, and the server. And you see that the browser is requesting a challenge. We send that back to the browser. We send it to the authenticator device. We'll choose this device and touch it, which means that we just created the credentials, and we send the challenge plus signature plus public key plus the raw ID to our server. And when we've done that, you see that the raw ID of my private key is this one, and my public key information is this. That's information that's been generated in this step. But if you want to log in, we click next, and we use the ID that we just got back. And we're going to send the username to the backend. It's going to create a raw ID. It's going to send back the raw ID of the private key and a challenge. We look for that private key on our authenticator device, sign a challenge, send it all back, and if all goes well, we've proven that we are who we are and we can authenticate without a password. Well, this is just fake, by the way, on the front page. It just lets you show the back and forth, but it illustrates the back and forth between the different parties. This website also has some more information and some browser support, but where it gets really interesting is the debugger, which basically lets you play around with all of these configuration values that you can pass along to the navigator.credentials.create and navigator.credentials.get methods. So if we do this right, I will say my name is Oslo, and my display name is NDC. And we'll leave the rest as standard, except we want to require resident keys. And resident keys is what I told you, that you can also store a user profile together with the public and private key pairs on your authenticator device. So we're going to try to do this. And then register. I'm going to use my device because I forgot my YubiKeys. But when I do this, we get back a whole bunch of information. And what we get back again are those objects that I talked about earlier. It will show us the client data JSON, and will show us the attestation object. But more importantly, we just created a public and private key pair for this website, for WebAuthn.me, and it's going to be linked to my user, Oslo. So if I try to log in next time, authenticate, we're going to call navigator.credentials.get. But instead of passing along a list of allowed credentials, we're going to just say, hey, browser, do you have some credentials saved? Well, it's not the browser, it's the authenticator device. If so, can I please show them? Can you please show them? And can I please use those instead of the public key or the private key ID that I've stored in my database? So I'm going to unclick this, and then authenticate, touch my Touch ID, and now my browser asking me, do you want to log in with San Diego or with NDC Oslo? If I click NDC Oslo and scroll down, we get the same object that we talked about before as well. But when you enable require resident key, you basically store your user profile for this website on your authenticator device as well. Now, it's worth mentioning that there's limited space on these devices, so you cannot do this for every website out there yet. But if there's a website you use a lot, this might be something that could be really, really useful. Let's move forward. If you don't have one of these keys, or you want to just develop, test, the Chrome DevTools or the Chromium DevTools have a WebAuthn pane that lets you fake these hardware credentials. Lets you create fake ones that can be USB or Bluetooth, and so you can debug your applications, which is really useful if you're trying to implement WebAuthn yourself. The link to the debugger I just showed you is webauthn.me/debugger. But what are some of the benefits of WebAuthn? Well, the first thing is it's private and public key-based authentication, which is more secure. You don't rely on passwords. It's a private key that's going to sign a challenge. It's a public key that's going to verify the challenge. It's phishing resistant because these credentials are based on an origin basis. So every time you register for a new website, it's going to create a new private and public key pair, and it's only going to work with the origin of that website. So you cannot use my credentials for WebAuthn.me for a website called WebAuthn.ne or .com or whatever. They're on an origin basis, which means they are phishing resistant. You can only store, or you only store public data in your database. A public key is public data. A raw ID of a private key is something that's not sensitive, so you only store those kind of things in your database. And should the inevitable or the worst case thing happen that somebody breaches your database, the only thing they can steal is some public information, and they will not be able to use that information to authenticate your users. You have fine-grained control over which kind of credentials to allow. Do you only want to allow internal ones, platform ones, or external ones like YubiKeys? Do you want them to have user verification instead of user presence tests? You can set all of that in the configuration object. And it's a better user experience because the only thing the user needs to do in the end is just touch ID, use Face ID, use the things that they use on their phone, on their laptops more and more daily. And lastly, no more passwords. Use public and private keys instead of passwords. But there's also still some issues to be solved. It's a newish, 2 years or so since it's been finalized API. So there's still some issues that need to be solved, or issues, some things that we need to figure out. The first thing is user credential management. Chrome has these settings where you can manage security keys, and you should be able to manage your sign-in data. But I've never been able to make it work. Maybe some other people have, but I personally have not been able to make it work, which means you cannot manage the credentials that are saved on your authenticator device through Chrome or through something else. If you use YubiKeys, you have the Yubico app, which lets you reset those YubiKeys and erase all of the credentials, but you cannot change the name for a certain credential or anything. It's either erase all or just leave it as it is. Next thing is cross-device credentials. These credentials are created on the device, on the YubiKey, on your chip in your laptop or in your phone. So you cannot transport them from one device to the other. So if I register this laptop and I want to log in on my phone, I will either have to log in on my phone and register those credentials for that phone as well, or use something like a YubiKey that supports both USB-C and Bluetooth. That way you can use the same YubiKey for both your phone and your laptop. Which means if you lose or your authenticator device gets stolen, you will be locked out of your account unless you have a way of recovering your account, which might be a password, which might be a secret, might be something else. But you should always have a fallback when you use WebAuthn, especially if you use it as the first factor, but also as a second factor. Should the user not have access to their authenticator app or to their device, they should still be able to recover their account and create a new credential for another device. So WebAuthn might replace passwords. I think they will. You see them more and more popping up these days all over the internet. But it will not replace token-based authentication or authorization, things like OAuth and OpenID Connect. It will also not replace identity providers like Auth0 or Okta or Ping or Identity Server or any of those things. It will only replace passwords. Instead of using a password to prove that a user is who they say they are, you're going to use a public and private key pair to prove that somebody is who they say they are. It's a W3C recommendation, which means that the specification has been finalized 2 years ago by now. And it works in all modern browsers on all devices as well. There's one caveat. The require resident key doesn't work on Firefox, on macOS, and I think on Android. But the basic functionality without resident keys works in all modern browsers on all devices. So where can I use this already? Auth0 supports it, so anybody who implements Auth0 can add this as a second factor and soon as a first factor. Google, GitHub, all of the bigger services out there have support for it, either most of the time as second factor, but also as a first factor. And if you use Auth0, you can either use external ones, internal ones, or both. And we will discover if the user has one of those things attached or has a device that has a biometric thingy built in, like Touch ID, and ask the user to register. And if not, we'll just go through a regular second factor flow for now, or a regular authentication flow once the first factor feature launches soonish. Lastly, WebAuthn.me. I've already shown you this, I already mentioned this. Should you want to learn more about WebAuthn, there's also a bunch of information and browser support on there, so it's definitely a resource that I can recommend. So let's summarize. Boo passwords. I don't like passwords, they're annoying, they get stolen all the time. I'm not good at typing, so I type them wrong all the time, even though I use a password manager, it's still annoying. One-time passwords are cool, but they're often used as a second factor, and they're not really the way forward because they also have other vulnerabilities or soft spots. And WebAuthn is way cooler because you use a proven, way more secure system of public and private key pairs. And you can just basically log in with the convenience of Touch ID, Face ID, whatever you want on the web. Some resources. Some more resources. I will publish these slides online, or they are online, at 1919.sambigo.tech. And that being said, are there any questions? Cricket sounds.
Yeah. You have created your key in your computer, and then suddenly it explodes.
Yep.
What do you do?
You need a backup mechanism to recover your account. Yep.
Users to
No. Your application should force this. For example, I'll explain to you how this works with Auth0, because that's how I know how it works. You can enable WebAuthn as a second factor, but if you want to enable this, you should also enable one of the other offerings that we have for second factor authentication. So there's a one-time password in SMS, that's a one-time password in mail, that's an authenticator app. And the user will be prompted to configure those whenever they want to register a new credential. So the user will not be able to register a new WebAuthn credential if there has not been a backup way configured. What you also can do is just generate backup codes or recovery codes like GitHub does. GitHub gives you a bunch of recovery codes they can use. You can also do this and send this to the user so they can keep this in a secure way. But there should always be a backup mechanism should the device not be available. Does that make sense to you? Yeah? Yes, sir.
Yeah, so since your key would be locked to your device, if you use your Mac, as you said, you cannot log in with the same key, obviously, from another computer. So what would be the strategy for accessing my one account from multiple devices?
So the question is, what would be the strategy to access your one account from multiple devices? Because if you use your MacBook's integrated authenticated device, you will not be able to use it on your phone or on your work laptop or something else. Either you deal with it and you register each device under your account, and you can use them all with the internal authenticator, or use one of those roaming authenticators, which is a YubiKey that works with all of your devices. Most of these YubiKey starting keys, they have support for at least 2 transport mechanisms, which means they might have support for NFC and for USB, or they might have support for NFC and Bluetooth, which means that you can use them with multiple types of devices. So if you only want to have one credential registered, that's the way to go. If you don't really care and you just want the convenience of using what's already in your device, you just register each device individually under your account.
So then you would tell your user to log in on your Mac first, and then...
Yeah, what we do is if we detect a user that has previously registered a device, but that key is not available on the device it's currently using, we ask them to enroll that device as well. So we prompt the user whenever they want to log in, hey, do you want to enroll this device as well? That's a strategy you could use. Yes, sir.
I guess you could register the mobile as the only device and use that even when logging into the...
No. No, because it has to happen on the device itself. It's the browser on the device that will do most of the heavy lifting. No. Well, there is a mobile app that can act as an authenticator device. So it's a software authenticator device. I forgot the name because I don't use it and it's not as secure as a real hardware authenticator. But it basically lets you use your phone as the authenticated device, use Touch ID or Face ID, whatever you have on your phone, and then log in into other devices. But that's not the recommended way forward. All the way in the back, mister? Is it possible to add user rules? Is that the question?
Yeah.
What do you mean with user rules? Oh, roles. Well, again, this only replaces passwords. So it does not do anything with your authorization system. If that's role-based access control, attributes, relationship-based, doesn't really matter. That's all stuff that happens after you've used WebAuthn. WebAuthn only replaces the password and maybe the username input as well. Make sense? Cool. Any more questions? Yes, sir.
Do you have any data like relating to adoption? If I put WebAuthn next to passwords on my login screen, how many people would WebAuthn today, you know?
I do have some data on that, but I forgot the data. We have done research with Auth0 on what users want versus what websites and services offer. And I believe it's something like 80% of users on the web would use biometric authentication over passwords if they had the opportunity. It's 81 or 2, I believe, but I will look up that data and I can show it to you later. But basically, if you give the opportunity and it's clear enough how to use it, users will want to use it. The thing is, it's new to users and they first have to get adjusted to it, and that's the step we're in right now. Bigger services offer it, users don't know it yet, so they first have to see others use it, but once the ball gets rolling, it will hopefully catch on. And users indicate that they would use it if they had the chance, but whether they say they would and whether they actually do, that's a different question. Yes, sir.
About the mobile again.
Mm-hmm.
This is built into browsers now. Does that mean I cannot use it in the native app?
No, it's a web authentication API, so it only works for web.
Even with a web view inside?
Yes, a web view is either a Chrome instance or a Safari instance, and I assume that those have the web authentication API available. Yes, because usually the recommended way to logging in into mobile apps is with a web view anyway. So you should be able to use that. There is a proposal from Apple to let mobile apps, native mobile apps, reuse the same credentials as WebAuthn credentials. At this moment, they're not using the same kind of credentials as their WebAuthn credentials, or if your application has Touch ID or whatever built in it natively, they use something else. But there's a proposal to let mobile apps also use the same credentials as WebAuthn credentials by registering the origin of the website and the application and making sure that the device knows that they are both the same origin. But that's just a proposal. That's not something that is working right now. Is that clear? Okay. Some more questions? Keep them coming. Going once? Going twice? You all want to get some food, I guess. Cool. Now, that being said, thank you very much. These slides will always be online, and if you have any more questions, I will be here. Thank you.